All right, so now we want to talk about nuclear power. And this first slide says it's actually neutrons which trigger the nuclear reaction. So this is for nuclear fission. So in nuclear fission, you have this radioactive substance, and it's almost on the verge of wanting to break apart into two substances. But you need to give it a little push in order for that to happen. That's what the neutrons do. So when a neutron enters a particular radioactive substance, it makes it want to undergo nuclear fission. But notice what happens. One neutron goes in, and then do you see three neutrons come out? And each of those three neutrons can trigger another nuclear reaction. So that if this was what was going on and you didn't capture some of those neutrons, then what you would have a runaway nuclear reaction if that was to occur, which is bad. So what we want is a method of controlling those neutrons. So I would want you to know, how does a nuclear power plant work? So this time I'm not going to go over the parts of it because we did that in an earlier lesson, and I will let you do your research. So I'm just going to tell you the words and you figure out what do they do. So I want you to know the words containment vessel. I want you to know the word fuel rod. I want you to know the word control rod. And I want you to know the word moderator. Okay, so do your research, because all of those are parts of a nuclear reactor. You should be able to tell me what's the purpose of the moderator. What's the purpose of the control rods? And this is illustrated in this video that you can watch. Okay, now you're not going to need to know about the United States nuclear power production. And you don't need to know about that. And you're not going to need to know about this scale for telling how dangerous a nuclear disaster is. Okay, then we talked about measuring radiation. So what I want you to know is, what is the gray? So know what is the unit gray? What does it represent? You don't need to know the formula for it. All right, you should also know what an RBE is. RBE. You don't need to know the numbers for different kinds of radiation, but I could give you the chart and you could look up those numbers on it. So that if I was to say, which is more dangerous, a heavy ion or an alpha particle, you should be able to look at that chart and decide which one's the more dangerous kind of radiation. And then you should also know what a sievert is. So SV. Know what the sievert is. And you don't need to know the formula for how to calculate the dose equivalent. Okay, and then if I was to give you a chart like this, then I could ask you what would happen if you received 1 sievert of radiation. And you could look it up on that chart. Okay, so let's not do that. Okay, then if I was to give you a chart like this, I could ask you, where does most of the radiation come from that you receive on Earth? And you can look it up on that chart. Okay, radiation and health. So this is a big one. I want you to be able to tell me how does radiation affect organic material. So don't worry about the inorganic material. So how does radiation, when it strikes living tissue, how does it cause damage? So you should be able to tell me that. Okay, and then what is the effect of shielding? So you should know which kind of radiation. So we've got the alpha particles, the beta particles, and then the gamma particles. So of those three, which is the one that takes the least amount of shielding to protect you from, and then which one requires the most amount of shielding? Okay, and then we also talked about that if you don't want to get irradiated, limit your time of exposure, and then also increase the distance from the radioactivity. All right, let's take a break. When we come back, we will finish our review for the Unit 4 exam by talking about the origin of the elements.